Hello, good morning. My name is Nishant Agrawal. I'm a VP of Engineering here at Ksolves. I primarily take care of artificial intelligence and machine learning domain here. So today we'll talk about one of the recent business cases that we did for our customer, which was in a refrigeration manufacturing domain. But this applies to other similar domains as well. For example, healthcare and energy. So the problem our customer was facing was of short cycling in refrigeration. So let me tell you what is the problem. So the problem of short cycling in refrigeration is that when the compressor starts and stops too frequently, which leads to energy loss, and fixing it requires time and money of the consumer and as well of the agent who is going to fix and the organization that is providing. And as you see, this is not specific to manufacturing domain. This applies to other domains as well, wherever there is reactive fixing or patching of the problem comes into picture, which is costly to the business. And it is avoidable. So the problem of short cycling in refrigeration is often fixed by adjusting the thermostat or the relay or making some changes in the compressor. So let's zoom out a little bit and see that this is a reactive maintenance, which is a common problem in domain. So what our customer wanted, and we collaborated with them on this, was moving from this reactive approach to more of a predict and prevent approach, predicting when the problem can happen and prevent it before it happens. Same thing can be done, as I said earlier, in other domains like healthcare, where there are multiple instruments into picture, where multiple machines are used, as well as in energy domain. For example, there are energy grids, instruments, control centers. So the same principle applies there also, moving from reactive approach towards a predict and prevent approach. So here we collaborated with our customer to understand their problem, to collect the right data in a scalable and sustainable way. And when I say data, it was about temperature readings, energy consumption, humidity, and compressor usage. So what we did was use the pandas and NumPy libraries to make sense of this data. And what our machine learning experts discovered was the underlying patterns in this data, which was variability by location, by manufacturer, by the season. So, and there are multiple other trends. So our ML experts were able to do this using a combination of cloud managed services on AWS, as well as using Python notebooks in this exploratory analysis. So we validated these trends with our customer and also with our customers and consumers to validate the ground truth, what our understanding is and what the data says. Both should reflect and confirm the same thing. So using this data and the exploratory analysis of this, our experts were able to model the short cycle occurrences. We were able to understand the compressor on time, its impact on the short cycle. We were able to forecast the energy consumption and the probability of failure. So all these things were helping our enterprise customers, and our enterprise customers was able to use this information to provide predictive maintenance. Before the compressor or refrigerator fails, we are able to, the organization and our customer was able to fix the problem before it happened. Because as I said earlier, fixing when the compressor has failed, that's a costly affair. So before it happens, using this, our customer was able to fix the problems. As part of this, we had set up multiple MLOps as well for automated deployment, versioning and monitoring of the model. And a lot of times after the initial deployment, the model drifts because there is new data which was not seen earlier in the historical trends on which the model was built, was seen earlier. So there is a model drift, and using this MLOps, we are able to see when the model drifted. We are able to enhance some features to the model, retrain it, and do a canary release of the model, which provided up-to-date prediction to the customer. So this was the whole life cycle of our engagement with the customer for the initial development, starting from requirement analysis, validation of our understanding with the customer, working on the model with the customer, validating the model, and providing sustenance operations to support the model whenever the model changes, new data comes into picture. So this was now it's a seamless system for our customer. And the benefits of this for our customers were not just in energy optimization and cost reduction, cost both in terms of repair cost or any legal cost. So this was all covered and reduced. This also improved the equipment lifespan. But the most important outcome of this was that our enterprise customer was able to apply for a patent for the intricacies that the system brought to them. So we are able to work with our customer to help them develop the system and also apply for the patent for this innovative system in refrigeration. As I mentioned in the beginning, the same movement from reactive fixing to the predictive and preventive maintenance can be applied to other similar domains as well: refrigeration, medical, and energy sectors, among the few. So this was an example of one of the projects that we did for our customers. We did many other such projects with our customers. If you are also facing similar maintenance challenge in manufacturing, healthcare, energy, or any other similar domain, Ksolves team is here to assist. Let us help you optimize your operations and significantly reduce your maintenance cost with our advanced AI solutions. Thank you.